Welcome back to Vibrations, Week 1. This is Class 7, I believe. I just finished Class 6. Not class, video 6. This is Video 7. I just finished Video 6, and I forgot to show the. Here is the actual with Excel. I've made what I tried to sketch out into this other piece right there. Not that matters, but here's another problem. Here's example 2 from Dr. Bob Selmer's notes to accompany the introduction. And we want to find, given this graph, what is the value of x for sinusoidal harmonic motion? We can see that it starts off there at 0. So that's a clue that this is a sine wave with the phase angle of 0, because it starts right there. Its amplitude is going to be, come up right here. Its amplitude looks to be 3, right? So x is equal to 3. And this says it's in inches, so we'll say 3 inches. And I like to go 4 sig figs, so I will try to remember to be a good role model. We can also see, it says, now what is the initial velocity? So now here's a question that can actually cause you a lot of pain and suffering, because it makes you think, right? So first off, what is the frequency of this? In order to find the frequency, we need to find the period. And we can see that it starts right here, and then it ends and starts again right there. So the period is right here. Tau. Looks like a backwards J, actually. So the tau is equal to 0.2000 seconds. So the frequency, I don't know why I said that. Okay. The frequency is 1 over the period, or 1 over 0.2, which is going to be equal to 5 hertz, which is going to have a omega of 2 pi, so the circular frequency. We got to use this circular frequency because we're using sines and cosines, and they need some radians inside them, otherwise they won't work. So if we put those into there, 2 pi times 5, we'll end up with 31.42. And these are radians per second. And we recognize that if we have an x is equal to x times the sine of omega t, an x dot is going to be x omega times the cosine of omega t. So initial velocity is going to be when t is equal to 0, we'll have 3 times 31.42. And so therefore x dot, let's put a dot, not a 0 up there, is going to be 94.3, and I didn't bother with the next sig fig, so assuming 3 sig figs is sufficient for an answer. In between calculations should always be done with 4 sig figs. 4 sig figs are acceptable for an answer. 3 sig figs are also acceptable, but don't give me more than 4. Don't give me less than 3. Okay, so here's another example from Bob's notes. Dr. Bob's notes. It's called Bob. So, given the following, I scratched something out right here. No, I guess I got it right. Yeah, okay, so I corrected that. Good. Given the following information, what is x? Okay, so we have initial values 3 inches. Initial velocity is 28 inches per second. And our frequency, natural frequency, is 7 radians per second. Okay, so let me see something. I think, did I make a mistake earlier? Let me see if I made a mistake earlier. I don't like making mistakes. I think I might have got rid of it. Should that be negative? Some reason I'm making that negative. I don't like that. Oh no, okay, I got you. Okay, so let's go to the second derivative. Okay, so the first, the initial thing, let me write this out. My brain's not into it. Is equal to a times the sine of omega nt, because I'm using an n right there. I'm going to keep using it. All right. So x dot, it's a function of time, is going to be a times omega n cosine of omega nt minus, there you go, say, b times omega n times the sine. That's what had me worried. I read my notes and I just jumped to the thing. All right, so and I wrote down, okay, so remember though, sorry, I should have put these in there. We already solved for these, so let me put this back in here. We had x naught, and then we had, no, we had x naught right here, and x naught right there, and then we had x naught dot over omega n. So we have x naught dot over omega n. Gotcha. Okay. So, looking back, so this is where that came from. We had this generalized equation right there, more detailed solution. So we're going to apply this more detailed solution to this right here. That's the big idea. Let's switch colors. Just I'm tired of that color. Nope. These cancel out right in there. So we'll also note. So this is an interesting problem. So when x, yeah, we gotta look over it carefully. So I'm gonna write this out. When x dot when x dot equals 0, x is equal to x. Is that true? I'm gonna pause. All right, so here's the issue that I should have recognized. Right. When the maximum happens in the position when the velocity is at a minimum, right? As we've seen before in other, this like this guy right here, right? When this is going to be a maximum when that's a minimum. So that's the idea that we are using, leveraging to make this statement, that the position is equal to the maximum when the velocity is at a minimum. So we have to determine what time that happens. So we will go ahead and set the velocity equal to 0. Right, so go 0, and then put in all the values that we know. We know x dot, we got 28 right there, and we're going to take the cosine of 7 times the time, and then minus, right, here's the initial position, is going to be, the initial position is 3, and then omega n is 7, and then we have the sine of 7 times time, right? So we can rearrange this with a value, and we can use the fact that sine over cosine is going to be a tangent, and these are the same values right here. So we'll have the tangent of 7t is going to be equal to, and then we will take, let's see, did I divide? I think it's going to be 28 divided by 3 and 7, or 21. And make sure that we're using radians. Let's write that in red. Use radians in your calculator. And we take the inverse tangent of this value and find that t is going to occur at, where'd you go? At 0.1325 seconds. So what we can find is that, well, now we go back into this equation right there and write x of 0.1325, and that should equal to that big X, is going to be equal to, remember this X dot, not, so 28 divided by 7 times the sine of 7 times 0.1325 plus x naught, which is 3. Get that right? 3 times the cosine of 7 times 0.1325. It's supposed to be a 7. And that ends up equaling, interestingly enough, 5 inches. So the answer to this one is 5 inches. All right, so I'll go on and do more examples in the next video. Thus end video 7, I think.